Well, good morning, Honors Algebra 2. It is Thursday, April 16th, and we are continuing on in Chapter 11 with Section 11.7, Multiplying, Dividing, and Simplifying Radicals. There's quite a bit to talk about today, but I'm going to try to streamline it and make it as efficient as possible. And let's go ahead and look over here at trying to simplify the product of two rational expressions. Now, we know here that we have four factors here, 3 times root 2 times 4 times root 18. So we can use the commutative property and move our factors around. And so what I'm going to do is I'm going to put my rational factors out front. I've got 3 times 4. And that's going to leave me with the root of 2, my irrational factor, times my other irrational factor, the root of 18. Now, there is more than one way to simplify this. I could start right now and say, oh, what's the root of 18? Well, that's the root of 9 times 2. And I could simplify this as 3 root 2 and then go ahead and keep going. But I noticed something that's great right here. Remember, when you have two square root terms, you can combine them and bring the two factors together underneath one square root symbol. So let's do that, because this will become a 12, and then I'm going to end up with the square root of 2 times 18. Let me go ahead and show that step. And why I like that is because 2 times 18 is 36, a perfect square. Okay, so I'm going to have 12 times the square root of 36, which is going to be 12 times 6. Well, what's the answer? The answer is 72, and I have just simplified this radical expression. Okay, now let's look at the next one. We have two radical factors again, but our radicand on both of these is a fraction. So let's do again. Let's combine the two square root terms and make one square root, and both of the factors will be together as one radicand. So let's go ahead and combine these two factors underneath one square root. Now, the beauty here is that both of these factors are inside the square root. I can go ahead and cancel here. So I've got 14 over 7 is 2 over 1, and 3 over 27 is 1 over 9. So I have the square root of 2/9. Now, I will tell you, the rule is, we'll talk about the summary of all the rules, you can't have a final radical expression here with a fraction inside. Okay, so we're going to have to simplify this. So we learned that we can take a fraction and split it up into a numerator with the root of 2 over a denominator with the root of 9. And how wonderful. The root of 9 simplifies to root 2 over 3. And there is my answer, okay? There is my answer to the product of these two radical expressions, or radical terms. Okay, now, notice here that the root of 9 simplified to 3. 3 is a rational number. Over here, I have the root of 5 over the root of 7. The root of 7 cannot be simplified, and I'm stuck with an irrational number in the denominator. That is a big no-no in algebra. You are not allowed to have your answer have a radical, have an irrational denominator, have a radical in the denominator. So we have a special technique called rationalizing the denominator. We're going to force that denominator to be a rational number. Well, how do we do it? Well, it's a special little trick we can use. And that is, we're going to multiply this fraction by 1. Well, that's not going to do any good to multiply this by the whole number 1, but we're going to change 1 to have a different format. And we're going to still multiply it by 1, but in the form of root 7 over root 7. This is still the value of 1. Now, I picked root 7 because I had root 7 over here in the original denominator. Now, look what happens. What I'm going to do, remember, I can combine these two square roots into the square root of 5 times 7 is 35. Down below, I'm going to end up with the square root of 7 times 7 is 49. And so what I have now is the root of 35 over 7. That is the root of, can the root of 35 be simplified? Does it have a perfect square factor? The answer is no. So I am done. There is my answer. And I took an irrational denominator and created a rational denominator with that special technique of multiplying by 1 in the form of root 7 over root 7. Excuse me. Okay, let's go to the flip side. And I have to have a little water here. Excuse me. Okay. Let's talk about our 3 important rules about simplifying radical expressions. In this case, square roots. Okay. Now, first of all, when I talk about the radicand, I've been talking about it. I should have probably written this on the first page, other side. The radicand is the term under the square root. Okay. The square root is 7. The radicand is 7. Excuse me. Here's my 3 rules. You cannot have a perfect square factor in a radicand for it to be in simplest form. We talked about that the other day, okay? So the square root of 75 has to be simplified to the root of 25 times 3, which is 5 root 3. Okay, now, what's the second rule? You cannot have a fraction as your radicand in your final simplified answer. No fractions. You cannot have a radical in the denominator. We already talked about that on the flip side. So, 3 things. No radical denominator, no fraction as a radicand, and no perfect square factor in the radicand. Get it out of there. Okay, now, let's try this one. We did one on the flip side, but let's try this again. I have an irrational number down here, okay? And so I have to rationalize it, and the way I'm going to do it is I'm going to multiply by the root of 5 over the root of 5. Okay, so now what do I get? The numerator becomes 3 root 5. The denominator, I'm going to show this step. You don't have to show this step, but I'm going to show it. It is the square root of 5 times 5, which is the square root of 25. I'm going to go to the side here. I've run out of room. 3 root 5 stays the same, and the root of 25, of course, is 5. And I have rationalized, I've created a rational denominator, starting with an irrational denominator. Okay, now let's move on. What if I have a fraction here? Okay, no, rule 2, can't have it. So what I'm going to do is I'm going to split that up into 2 radical terms, one in the numerator, one in the denominator. So I'm ending up with the square root of 7 over the square root of 8. Okay, well, I don't have fractions under my roots, but I have a radical in the denominator now. Now, you could multiply numerator and denominator by root 8, but I will tell you, you'll have to do a lot of simplification, so don't do that. My husband is mowing the lawn. Sorry about that. Okay, now, let's go ahead and do this first. Let's go ahead and simplify the root of 8 first. It has a perfect square factor, doesn't it? And the root of 8 is the root of 4 times 2. So let's go ahead, and we've got the root of 7 is just hanging out in the numerator. The root of 4 is 2. Bring it out, and I'm left with a 2 inside the square root. Now, I have root 7 over 2 root 2. Root 7/8 became root 7 over root 8, became root 7 over 2 root 2. Now, I've still got a radical term in the denominator. Can't do it. What am I going to do? Now, leave that 2, leave this rational number alone, and let's get rid of the irrational number. So what we're going to do is we're going to multiply just by root 2 over root 2, and let that rational number just hang out for a little bit. Now, keep going. I'm going to have in my numerator combine these 2 to the root of 14 over 2 times the square root of 4, which is going to give me the root of 14 over 2 times 2 is 4. Now, I'm going to box that. I am done. Don't think for a second that you can reduce 14/4 to 7/2. This cannot be reduced with this because this is a square root and this is a rational number, okay? They are not, they're not in the same form, and so you cannot reduce anything here whatsoever. Okay, we've got an irrational over a rational. We are done. Now, let's look at this. Okay, now this is different. I have a square root divided by a square root. Could I reduce that? You betcha. I can treat that as this. That is 9, and then 3/24 becomes 1/8. Okay? That's okay. They are both square roots. Here, they were not. Here, they are. Now, we know the square root of 1 is what? We know it's just 1. So that's going to be a 9 there. Now, we've already simplified the square root of 8, so I'm not going to go through all the steps again. The square root of 8 is the square root of 4 times 2, which is 2 root 2. 2 root 2. Okay. Now, okay, this looks very familiar. Let's go ahead and rationalize the denominator by multiplying by root 2 over root 2 and see where we are now. I'm going to have 9 root 2 over 2 times root 4, which is 9 root 2 over 2 times 2, which is 4. And I have a simplified fraction that now meets all of my requirements for my rules. Okay? I do not have a perfect square factor in the radicand. I do not have a fraction in the radicand, and I do not have a radical denominator. Okay? So we did a lot of things on that one. Now let's go to the next one. We have a square root times a square root. And so let's make this into an improper fraction. That's going to be 24 sevenths times the square root of 7/3. Now I have a square root times a square root. I am allowed to combine these two and put both of the fractions under the radical sign. Okay, now 7 over 7, we can now cancel them. They're right both inside. 24 over 3 is 8 over 1. And lo and behold, this whole thing up here has just simplified to the root of 8. Okay, so I've gotten rid of my fractions. And I've gotten all the way down to the root of 8, but we still have a perfect square factor here. That is the root of 4 times 2. And once again, the root of 8 is showing itself. And we know now it's 2 root 2. Okay, let's go one more thing to talk about. And that is, oh, you know what I did? I erased something that I wanted to show you. So let me just put that up there. It's the root of r times 5 minus root r. Root of r times 5 minus root r. I got to show you how to do distributive property. Woo, almost lost that. Okay, now I have a 3 times a root of ab squared times negative 2 times root a. These are all factors, okay? All of them are factors. So I'm going to rearrange my factors. I have 3 times negative 2 times the root of ab squared times the root of a. Commutative property, people. I just rearranged and put my rational factors in the front and my irrational factors in the back. Okay, well 3 times negative 2 is negative 6, isn't it? Now, let's look what we have here. These are both square roots. We can combine them into ab squared times a, okay? Well, you know what I'm going to do? I'm going to actually change that to a squared b squared. Are you okay with that? A times a is a squared and then b squared. Final answer, negative 6. What's the square root of a squared? Previous lesson, a. What's the square root of b squared? B. And I have simplified this expression into negative 6ab. Final thing I want to talk to you about is how do I do the distributive property when I have radicals? Well, I have a root r out front. I'm first going to multiply it by 5, and I get 5 root r. Now, please put your rational factor in front of your irrational factor. You always put 5 root r. You don't put root r times 5, because I'll tell you what can happen. You have root r, 5, and some people get a little sloppy, and it's like, where does that 5 go? Is it under the root or not? And so if you put the rational number out front here, it's very clear that it's not part of the root at all. Now, let's put a minus sign and let's go back. I have root r times root r is root r squared. Root of r times r. Well, we know what's going to happen here. Let's get our final answer, 5 root r minus r. And I am going to box that. And that is how we do the distributive property using radicals. Alrighty, so that was a lot today. I tried to do it as fast as possible, but look at that board. Okay, we covered a lot. Now, tonight you're going to be simplifying some of these radical expressions with multiplication and division. And you've got a mixed review and you've got a self-test. And then that'll prepare you. Friday, you will have a quiz. And your quiz will be over, let me look real quickly. Yeah. It will be over 11:4 to 11:6. This is 11:7. So we're just going to go through 11:6, okay? Open note, open textbook. Okay. So, miss you guys. I hope you're doing well with these radicals. If you're having any trouble at all with them, please come to the Zoom meeting today at 11. I've seen 2 or 3 people or 4 on a regular basis. I would love to see more people. Some of you guys, and there's 15 of you, some of you I have not seen for 4 weeks now. So no pressure, but please come to the Zoom meeting. It's fun and I love helping you. So anyway, have a blessed day. I may see you at 11, and I'll definitely see all of you here tomorrow to explain our next concept. Have a blessed day. Bye-bye.